So I think this diagram gives you one online student. Okay. So Fardeen, yesterday you had asked, see the two plates of the cell, are they at same potential? Okay. So it depends. So here I am showing you one more picture here, which I had not shown yesterday. You see, a cell is made up of two electrodes and electrolyte. Let's not get into those details, but different electrodes are used. See, magnesium, zinc, iron, hydrogen, so on and so forth. Now, you see, if you are using magnesium, then magnesium electrode potential will be minus 2.35, and say something like copper will have plus 0.34. Okay, so these are the electrode potentials. You understood? So therefore, the potentials developed by these electrodes are so and so. So what is important is not the individual electrode potentials. What is important is the potential difference between the two electrodes. Is that clear? Hello?
Yes, sir.
Right. Done. And I have also included that in yesterday's compared to yesterday. If you see here, I have included this one. I hope you know what I mean by this. A charge here, it will experience electric force, right? And at the same time, this charge will also experience. This charge will also have energy, potential energy. Understand? See, this body here has got both. What? If I leave my hand, it starts accelerating. That means there is electric force. Sorry, there is gravitational force. At the same time, since I have done work against gravity to bring it to this point, it has also got potential energy. So this region I can use a term called, this region I can define it either by gravitational field or potential field. Similarly, I can say here it is electrostatic field, or this region is what? Electrostatic field everywhere here, or you can also define it by potential field. If you define it by electric field, then you will use this formulation. Electric field, you will use this formulation. If you use potential field, then you will use this formulation. Okay, so what is the electric force experienced by this body here? The electric force experienced by the body will be K Q by R square. R square. And what is the potential energy of the charge here? K Q by R into whatever charge you place. If you are placing charge Q there, it will have potential energy Q by R.
In to find the electric, electric energy, means like.
Wait. No, see, did I use the word electric? See, now electric field is there. Here there is already electric field in this region.
At that point.
There is electric field. At this point, if you want to know the electric field, then you have to use this formula.
Like Q is like the small q is the q of the small object.
The charge that, see, the small q stands for the charge that you are going to place here.
It is divided.
Right? The value of the electric field at this point. Right? The value of the electric field at this point is it depends upon the charge and the distance. K Q by R square. That whole entity gives you a value, which is the electric field at that point. What did I say?
The value of
K
charge of the
gives
the value of the electric field.
At that point. So if you go to some other point, what happens to the electric field?
It will change as the distance.
As the distance changes, it is changing. Understood? That's all. So its value is something here, its value is something here. Okay. Just like how if you have lit an incense stick, agarbatti, if you come near it, you will have lot of smell. Intensity of smell will be great. Now as you keep moving away from it, the intensity goes on decreasing. Similarly, if I hold a torch right into your eyes, you may not be able to open your eyes. So as I move my torch away from you, the intensity decreases. So therefore the brightness decreases. Understood? You get that feeling. Okay. Now same way, electric field is also similar. Right? If you come closer, its intensity is more. If you go further away, its intensity decreases. What is the value of the intensity? That is given by this formula. Is it clear? By this formula. Okay, it is given by this formula. Which formula?
KQ by
R square. This formula gives you. What is it? It is giving the value of the electric field at this point. Here I am not placing any charge. Electric field is there. Here there is a gravitational field. Now, if you place a charge Q here, if you place a small charge Q here, then this charge Q will experience force. How much force will it experience? This quantity into Q. That much force it will experience. Is that clear?
Yes, sir.
Hello, everybody there?
Yes, sir.
Now, at the same time, I have placed this charge Q. Look at it from a different perspective. Then this charge will have potential energy given by KQ by R into Q. Correct? The potential energy of the charge, you simply multiply it by the potential. The electric force, you simply multiply it by electric field. Correct?
Yes, sir.
So that is the idea behind this, and this is an inclusion that I have done with respect to yesterday. That is, the potentials of each of the electrodes will be different. Clear? So yesterday we have discussed up to this point. Am I right?
Yes.
Now let me go further. Okay. So now voltage is also the last line. I hope you can all read. You can read the last line. So the last line you can see the voltage is also known as electric pressure, electric tension, or electric potential difference. Now understand this. Between the two electrodes, you have got potential difference. This electrode is at some potential, this electrode is at some potential. The difference of the two potentials. V1 minus of minus V2. That gives you the potential difference. Loud?
Yes, sir.
So electric pressure or electric tension or electric potential difference is the difference of the electric potential between 2 points. In static electric field, what does this signify? So there is potential difference between those 2 points. What does it signify? What does it feel? How does it physically manifest? Okay, what is your question?
No, sir, means like you told what does static field signify? You told us. So means it is that means the object is not, it has charge and it is not moving because of.
No, don't make some assumption like that. See, I did say. See what I was reading this and explaining.
I got confused.
You are always getting confused because you are always sitting in my class. You are thinking. At home you should think. And when I give you time to think, you must think. When I am teaching, you should be with me. See, when I am teaching, you are not with me. You are somewhere else. Okay, now be with me. Voltage is also known as electric pressure, electric tension, or electric potential difference. It is the difference between the electric potential between 2 points. See here the 2 electrodes, magnesium and zinc. They are the 2 electrodes, they are at different potentials. So V1 minus of minus V2 gives you the potential difference between the 2. Correct? In static electric field, see, you will study something else, dynamic electric field. If the charge is moving, then you will have electric field which is dynamic in nature. Okay? Or the magnetic field is changing, you will have electric field which is dynamic in nature. That you will study in PUC2, and some part you will study in your next chapter. So in static electric field, it corresponds to, what does it mean? It corresponds to work done needed per unit charge to move a test charge between 2 points. Now let me explain this point to all of you, because we will have to solve numericals on this point. Okay, see, now this point is say at some potential, say V1, and if this point is at some potential V1. Okay, now if I place a charge Q here at this point, what will happen?
An electric field is created.
Because of the charge, electric field is created around it. Okay. Now I have placed a charge Q at the position V1, where see this is space. At this point, the potential is V1. Now, if the potential at this point is V1, if I keep a charge there, what will happen to the charge?
It will get the potential energy.
Excellent. Fardeen is doing a good job. So its potential. Okay, thank you. Its potential energy is QV1. Understood? Now, if I keep the same charge at this point, where the potential is V2, so its potential energy will be QV2. Understood?
Yes.
That's all. Now this point is at potential V1, this point is at potential V2. The potential difference, this I'll call it as A, this I'll call it as B. Now VAB is what? The potential difference between the two, V1 minus V2. Got it? Now all this you understand very carefully. Now what? So this means I will measure the potential, I'll get some value. I measure the potential at this point, I'll get another value. That difference will give me another value. Clear? Now what does this value mean? See, your height is 5 feet 3 inches. What does it mean? It means your tallness, how tall you are. That is the tip of your head with respect to the toe. Understood? That's all, right? Now here, this value VEB, potential difference, what does it signify? Okay, what it signifies, you see here. Supposing, you see here, now be very careful. When I say the potential at A with respect to B, okay, that means now I am measuring the potential with respect to this. And now if this is a higher potential, I will mark it as plus. If this is a lower potential, I will mark it as minus. What did I say?
If V1 is at higher potential, we mark it as plus, and V2 is at lower potential, we mark it as minus.
Understood? Now say this is 3 volts and this is 2 volts. Understood? This is at higher potential than this. I am marking it plus, I am marking it minus. Now somebody should not sit there and say, oh, it is the minus value. No, sir. Minus means it is lesser than this. I'll tell you, since science and mathematics are slightly different. Understood? You have to understand the meaning of plus and minus in physics. Here plus means it is at higher potential, minus means it is at a lower potential. It doesn't mean that the value is lower. It can be 2 volts and this is 3 volts. This is at higher potential. Did you get it? Hello? Right.
And so if lesser potential means it can be lesser as compared to the first potential, or it should be lesser than the reference potential.
Where is the reference point here?
No, sir, if we take...
Where is the reference point? Where is the reference point I have shown?
No, sir, we usually take the value with
Good. Okay. So you can take some point as reference point. Say this point you take as reference point and assign the value V is equal to 0. For example, for this pen, I will take this table as the reference, gravitational reference. And so the potential of the table is 0. Now this point has got some potential with respect to table. Got it?
Yes, sir.
I can take even this point as reference. Can you see this point?
Yes.
This is also at reference. Now, any point above this, with respect to gravitational field, any point above this is at positive potential. This is 0 potential. This is negative potential. Got it?
Yes.
Now, this is at some potential, say V1. This is at another potential, say V2. Now, this is at higher potential than this. Got it?
Yes, sir.
And this is at higher potential than this. Got it? I hope this idea is clear. Okay,
Yes,
thank you so much.
Yes, sir.
Thank you, friends. So this is at potential V1, this is at potential V2. I'm just showing you some values here.
Actually, my doubt was that, like, if the second potential is also above the reference point or lesser, but it is less than the first potential, still it will be negative or it will be positive?
It will be negative, man. You didn't understand what I wrote here. I wrote here 3 volts and I wrote here 2 volts. This is still a positive number, no. But this is less than this, no.
I thought like if it is less also it will be negative.
Hey, is it not less? Hey, this 2 value is less than 3, no?
Yes, sir.
Then that is what I told. You didn't see, you should follow. See, I'll tell you again, all of you, you should follow every word that I speak very intensely. No word coming out of my mouth is a faltu word. I repeat, it is not a faltu word. I am not teaching nonsense here. Every word is concentrated. So if I have written some number here, it means I wrote this number deliberately to tell all of you that if this is at potential 3 volts and if this point is at potential 2 volts, this is at a higher potential than this. Correct? Even though this number is positive, I will still write that the potential at this point is negative and the potential at this point is positive. This positive sign means it is at a higher potential. Negative sign means it is at a lower potential. Is that clear, Mr. Aryan?
Yes, sir.
If anybody has doubts, you ask here. After I move forward, if you ask, I will lose track of what I want to teach you. You have to put all your energy, all your concentration in my class. I repeat, if
that V2 is less than the reference point, that time still the volt also will be negative.
No. See, this is the problem. Did I ever use the word reference in my discussion today? You tell me.
No, sir. Yesterday
Did I use? Listen. See, your question should be clear, gentlemen. Otherwise, you will also get confused. You will confuse me, and the whole class will be confused. Now, please understand. Whenever I say this voltage is at some voltage V1, that means there is some reference point with respect to which I am measuring this voltage. That is understood. Hello?
Yes, sir.
So that reference point, I can choose any reference point and assign it a value 0. Just like how I took this table as reference and assigned it 0. Once you specify the reference point, that holds good for the entire discussion. Got it? So with respect to this reference point, this is V1. With the same reference point, this is V2. Got it?
Yes, sir.
So references will not change. See, if you are, so now don't get unnecessarily confused. The reference point is same always. So with respect to this reference, this is V1. With respect to the same reference, it is V2. The potential difference between these two is V2 minus V1 minus V2. That's all. What is your doubt?
So if V1 and V2, if they have the same potential difference, then it will.
Then the potential difference between them is 0. See, now this is
the value will be less, no, sir.
See, if this V1 is equal to V2, then V1 minus V2 will be 0. The potential difference is 0. The potential difference is 0. The potential at each point is fixed. The potential difference is 0. Got it? Hello?
Yes, sir.
Yes, sir. Also, both are same, sir. We have to take both as positive or negative.
ಏನು ಕಲಿಯೋದಕ್ಕಾಗೋದಿಲ್ಲ ಏನು ಹಂಗಂದ್ರ ನಾ ಏನು ಕಲಿಸ್ಲಿಕ್ಕತ್ತೀನಿ ನೀವು ಏನು ಕಲೀಲಿಕ್ಕತ್ತೀರಿ ಅದಕ್ಕೆ ಸಂಬಂಧ ಇಲ್ಲೇನ ಸಿ ಐ ರೋಟ್ 2 values man 3 volts and 2 volts they are the values of the potential see ನೀವು ಮನೆಯಲ್ಲಿ ಓದಬೇಕಮ್ಮ ನೀವು ಕಷ್ಟ ಪಡಬೇಕು ನೀವು ಚೈನಿ ಪಡ್ತೀರಿ ಮನೆಯೊಳಗ ವಿಡಿಯೋ ನೋಡ್ತೀರಿ ಟಿವಿ ಗೇಮ್ಸ್ ಆಡ್ತೀರಿ ಹುಚ್ಚುದ್ರಂಗೆ ಇರ್ತೀರಿ ನೀವು ಪ್ಲಾನ್ ನೋಡು ನಾನು ದಿನ 4 ಗಂಟೆಗೆ ಹೇಳ್ತೀನಿ ನಾನು ನೋಡಿ ರೆಡಿ ಆಗಿ ನಿಂತಿರ್ತೇನೆ 6 ಗಂಟೆಗೆ ಇಲ್ಲಿ ಕರೆಕ್ಟ್ ರಾತ್ರಿ 10 ಗಂಟೆಗೆ ಮಲ್ಕೋತೀನಿ ಇಡೀ ದಿವಸ ಕೆಲಸ ಮಾಡ್ತೀನಿ ನೀವು ಪ್ಲಾನ್ ಮಾಡ್ಕೊಂಡು ಜೀವನ ಮಾಡಬೇಕು ಹಂಡ್ ಬಂಡ್ ಜೀವನ ಮಾಡಬಾರ್ದು ನಾನು ನಿನ್ನೆ ಕ್ಲಾಸ್ ಮಾಡಿ ವಿಡಿಯೋ ಕಳ್ಸೀನಿ ನೋಡಿದ್ರೇನಾ ನೋಡಿಲ್ಲ ಅಟ್ ಲೀಸ್ಟ್ ಕರ್ಸರಿ ಅದನ್ನು ಫಾಸ್ಟ್ ಫಾರ್ವರ್ಡ್ ಮಾಡಾರು ನೋಡ್ಬೋದು ದ ಹೋಲ್ ವಿಡಿಯೋ ಆಫ್ 1 hour ಯು ಕ್ಯಾನ್ ಸಿ ಇಟ್ ವಿದಿನ್ 10-12 minutes ಅದು ಮಾಡಿಲ್ಲ ನೀವು ಸಿ ಯು ಡೋಂಟ್ ವಾಂಟ್ ಟು ಪುಟ್ ಎನಿ ಎಫರ್ಟ್ ಯು ವಾಂಟ್ ಟು ಕಮ್ ಅಂಡ್ ಸಿಟ್ ಇನ್ ಮೈ ಕ್ಲಾಸ್ ದಟ್ಸ್ ಆಲ್ you will not get knowledge. You will ask some questions, it means yellow over the other. One question in there?
Sir, if it is like 3, V1 is 3 and V2 is also 3, like both we have to take the positive values or minus negative.
Okay, yeah. See, now, see here. V1 is 3 volts.
Even
V2 is, see, I didn't take negative value, man. See, the value of this is 3 volts, the value of V2 is 2 volts. So the value of V1 is plus 3 volts, the value of V2 is plus 2 volts. Correct? Hello? Now, I want to know the potential difference between the two. I want to know the potential difference between the two. What should I do?
negative.
Then I will use this sign. See, first day only I taught you mathematics. I give you one apple, plus 1. I give you another apple, plus 1. How many apples you have? Then this plus. See, this plus signifies what? Arithmetic addition. When I ask you how many apples you have, you should use this. If I give you one apple, I am giving you plus. What does this plus stand for? I give. Now, I take one apple from you. Then I will write it as minus 1. I will write it as minus. How many apples you have? Then I will again use a plus sign. Whenever you want to total, you will use plus. So here, how many apples? I have given you one apple. I took one apple, so the number of apples you have is 0. When I ask you the potential difference, then you will use a minus sign. Clear? Hello?
Yes, sir.
See, this is how you should understand. Plus minus ಏನದಲ್ಲ ಅದರದ್ದು ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಬೇರೆ ಇರ್ತದ. ಅದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಈಗ ನೋಡಿ ಆಪ್ಟಿಕ್ಸ್ ಅಲ್ಲಿ ಪ್ಲಸ್ ಮೈನಸ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಬೇರೆ, ಮೆಕ್ಯಾನಿಕ್ಸ್ ನಾಗ ಬೇರೆ, ಇದ್ರಾಗ ಬೇರೆ. ಅದಕ್ಕೆ ಇದ್ರ ಮನಸ್ಸು ಕೊಟ್ಟು ಕಲಿಬೇಕು. ಯಾವ್ದೋ ಒಂದು ಕಲ್ತು ಬಿಟ್ಟ ಎಲ್ಲದಕ್ಕೂ ಅದಲ್ಲ. ಬಹಳ ನೋಡಿ, ಸೈನ್ಸ್ ಅನ್ನ ಸರಿಯಾದ ಪದ್ಧತಿಯಲ್ಲಿ ಕಲ್ತರ ಭಾರಿ ಈಸಿ. ನೀವು ಹೆಂಗ್ ಬೇಕಾದ್ರೆ ಹಂಗೆ ಕಲ್ತ್ರ ಅದು ಭಾರಿ ಡಿಫಿಕಲ್ಟ್ ಇರ್ತದೆ ಸೈನ್ಸ್. ಅದ್ರಾಗೂ ಫಿಸಿಕ್ಸ್ ಬಿಕಮ್ಸ್ ದ ಮೋಸ್ಟ್ ಡಿಫಿಕಲ್ಟ್ ಸಬ್ಜೆಕ್ಟ್ ಫಾರ್ ಆಲ್ ಆಫ್ ಯು. If you learn it properly, it is like riding a bicycle, a jolly ride on the bicycle, an adventurous drive. Otherwise, it will be the most difficult subject. So, ಮನಿ ಒಳಗೆ ಹೋಗಿ ಕೆಲಸ ಮಾಡಿ, ದಿನಾಗ್ಲೂ 1 ತಾಸು ಅಭ್ಯಾಸ ಮಾಡಿ, ಹೇಳಿದ ಮಾತು ಕೇಳಿ. ನಾನು ವಿಡಿಯೋ ಮಾಡಿ ಕಲಿಸ್ತಾ ಇದ್ದೀನಿ, ಅದನ್ನ ಸೇರಿದ್ರೆ ನೋಡ್ಕೊಂಬರಕ್ಕೆ ರೆಡಿ ಇಲ್ಲ. ನೀವು ಲೈಫ್ ಭಾಳ ಈಸಿ ತಗೊಂಡಿರಿ. ನಿಮ್ಗೆ ಎಲ್ಲರಿಗೂ PUC 2 ಬಂದ್ಮೇಲೆ ಗೊತ್ತಾಗ್ತದೆ. ಈಗ ನೋಡಿ ನನ್ನ ಮನೆ ಮುಂದೆ ದಿನ 10-20 ಮಂದಿ ಬಂದು ನಿಂದಿರ್ತಾರೆ. ಟ್ಯೂಷನ್ ಕೊಡ್ರಿ, ನಮ್ಮ ಫಿಸಿಕ್ಸ್ ಡಿಫಿಕಲ್ಟ್. ಐ ಕಾಂಟ್ ಹೆಲ್ಪ್ ದೆಮ್. ದೇ ಡೋಂಟ್ ನೋ. ಐ ವಿಲ್ ಟೆಲ್ ದೆಮ್ ಐ ವಾಂಟ್ ಟು ಹೆಲ್ಪ್ ಯು. ಐ ವಿಲ್ ಆಸ್ಕ್ ದೆಮ್ ವಾಟ್ ಈಸ್ ನ್ಯೂಟನ್ಸ್ ಲಾ, ವಾಟ್ ಈಸ್ ಡಿಸ್ಟೆನ್ಸ್, ವಾಟ್ ಈಸ್ ಫೋರ್ಸ್. ದೇ ಕೆನಾಟ್ ಓಪನ್ ದೇರ್ ಮೌತ್. ವಾಟ್ ಕ್ಯಾನ್ ಐ ಟೀಚ್ ದೆಮ್ ಅಟ್ PUC 2? I say sorry. They are ready to pay any amount of fees. But I say no, I cannot. I cannot do any justice to them. ನಿಮ್ದು ಹಂಗಾಗ್ತದೆ. ಈಗ ಹಿಂಗೆ ಆರಾಮ್ಸೆ ಇದ್ಬಿಟ್ರೆ ಹಂಗಾಗ್ತದೆ. ಈಗ ಸ್ವಲ್ಪ ಮನಸ್ಸು ಕೊಟ್ಟು ಅಭ್ಯಾಸ ಮಾಡ್ರಿ, ಸ್ವಲ್ಪ ಕೊಟ್ಟರೆ ಅಭ್ಯಾಸ ಮಾಡ್ರಿ. ನೀವು ಉಳಿದಿದ್ದ ಹವ್ಯಾಸ ಬಿಡ್ರಿ. ಎಕ್ಸ್ಟ್ರಾ ರೀಡಿಂಗ್ ಅದೆಲ್ಲ ಮಾಡಬೇಡಿ. ಸ್ಕೂಲ್ ಬುಕ್ಕನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ನಾ ಕಲಿಸೋದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಸಾಕು. ಸ್ಟಾರ್ಸ್ ಏನಾಗ್ತದೆ, ಅದೆಲ್ಲಿ ಹೋಗ್ತದೆ, ಮೂನ್ ಈಸ್ ಗೋಯಿಂಗ್ ಎವ್ರಿ ಇಯರ್ 3 centimeters away. Why do you want to do all that? What is the use of all those things? Anything that helps you to understand today's concepts, the science of today, you ask questions on that. Understand? Don't see. I know I am an engineer. I can go on talking about everything. Please, ಇದು ತಿಳಿತೇನೆ ಈಗ? Right. So positive ಅಂದ್ರೆ ಏನ, number ಅಂದ್ರೆ negative number ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Now did you understand the potential difference between these 2 points? What is the potential difference between 2 points? So you don't worry. See, you say, sir, if this point is at potential V1 and if this point is at potential V2, then what is the potential difference? Potential of 1 with respect to 2. Potential of 1 with respect to 2 is V1 minus V2. So whatever is this value, you write here. Whatever is the value here, you write here. Got it? So, supposing the value of V1 is plus 3 volts and the value of V2 is plus 2 volts. Then, what is the potential difference? This becomes 1 volt. Potential of 1 with respect to 2 is 1 volt. Got it?
Yes, sir. Yes, sir.
Now, potential of V is plus 3 volts. Potential of V2 is also plus 3 volts. Then, what is the potential difference? 0 volts.
0.
Potential of V1 is plus 3 volts. Potential of V1 is minus 3 volts. Then what is the potential difference?
6
volts.
6 volts.
ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ಅಷ್ಟೇ, ಇನ್ನೇನು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋದು ಬೇಕಾಗಿಲ್ಲ. ಏನಾರ ವ್ಯಾಲ್ಯೂ ಇರಲಿ. Now what is the potential of 2 with respect to 1? Here with these values. What is that? Tell. Hello, what is the value? Come on, V21. Potential of 2 with respect to 1.
Minus plus.
Potential of 2 with respect to 1. Correct? Sorry.
Minus plus 3.
So potential V21. Potential of 3 will be what? Plus 2 minus of plus 3. This gives you minus 1.
Minus 1 volt.
ಅರ್ಥ ಆಯ್ತಾ? ಅಷ್ಟೇ, ಇದೇನು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋದು ಬೇಕಾಗಿಲ್ಲ. Right. Okay. In potential difference ಅರ್ಥ ಆಯ್ತಲ್ಲ? Now students understand. Absolute potential. What is this? This value, that is, if I say this value is plus 3 volts, then plus 3 volts becomes the absolute potential. That means it is plus 3 volts with respect to some reference. Some reference whose voltage is 0. Got it?
Yes, sir.
It is understood. See, if you say my height is 158 centimeters, that means the tip of my head to the toe of my head to the the tip of my head to the toe. If I am in upright standing position or my body is stretched properly, not bent, then the distance of the head to the toe is 158 centimeters in mathematical terms. Correct?
Yes,
That is how you have to understand. It is understood that you are measuring the tip of my head with respect to the toe. Clear? Same thing here. Okay. Shall I rub?
yes, sir.
Shall I rub on KCET? Online students, sir. Very good. Now, what is the significance of this potential difference? Potential difference, calculate madidappa, one formula kotte mugidalla. It is not done. I have just told you, I have just told you to calculate the potential difference. What is the significance of this? Okay. Now you see, I will take a charge Q is equal to 1 unit. What did I do?
The charge of
I took a charge of 1 unit, placed it here. So this charge will have potential energy. What is the potential energy of the charge? QV1. Got it? Hello.
Yes, sir.
Is QV1. Okay. Now you see, this charge, this is at higher potential. This is, and say V2 is another point here. V2 is another point. So V2 is at some potential. V1 is at some potential. Now you see here, V2 is at higher potential than V1. Assume. See, you can assume and do some things. V2 is at higher potential than V1. Okay? Or it can be V1 is at a higher potential than V2. Or V2 is equal to V1. All this is possible. Okay? Now just aram se understand this. See here. How much work, so the work done by me to lift this from here to here. I have to pull it now. I am applying force in this direction and the displacement is also in this direction. Correct? So I am expending energy to pull it up. So the potential energy of this will increase. Got it?
Yes.
Hello?
Yes, sir.
So force into displacement gives you this. So the potential energy will increase if I go from lower potential to higher potential. If you go from higher potential to lower potential,
it will increase.
thank you so much. Okay. Now same way. Now all of you observe. I am moving it horizontally in the gravitational field. Did the potential energy of this increase or decrease?
It will not change.
It's same.
It is same. It is same. Correct? No? Why it is same?
Because
Because the distance is same.
ಏನದು ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಸೇಮ್ ಅಲ್ಲ ಅವ್ರು ಯಾರೋ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಸೇಮ್ ಅಂತ ಹೇಳಿದ ಏನದು
No, the distance between the earth and the object is same.
Okay, did the energy of this increase or decrease? It is same. Why it is same?
because the object means the height of the
There's no energy applied for displacement.
No,
There is no vertical distance.
So neither moving from a higher to lower or from lower to higher.
Who is this fellow? Who is this gentleman?
Something.
Good for this. See, man, I told you, you use a proper terminology. What is this? Equipotential plane, equipotential surface. Kalsi lena. See, ನಾನು ಒಂದೂವರೆ ತಾಸು ಕಲ್ಸೇನಿ. ನಿಮ್ಗೆ ಅದು ಏನೂ ಉಪಯೋಗ ಆಗಿಲ್ಲ, ಡಯಾಗ್ರಾಮ್ ಎಲ್ಲ ಕೊಟ್ಟು ಕಲ್ಸಿದ್ದೆ. See, these points are at same potential. Hello. This is also V1, this is also V1, this is also V1. So V1 minus V1 is 0. So this is equipotential surface. So the potential energy of this is QV1, QV1, QV1. So the potential energy will not change because it is equipotential points. Yes, it is at the same height from Earth. But this is the terminology you must use. If you simply say some distance, same point, higher point, then see the other person can understand or misunderstand it in his own ways. When you write answers also, you have to be very specific. That is physics. Physics teaches you a lot of things. One of the things is discipline. See, you are disciplined in writing, in discipline in understanding. See, I am trying to induce these qualities in you. Please get it induced. Right. So, this is the potential difference. Now you see, students. If I move this from higher potential to lower potential, its potential energy decreases. If I move it from lower potential to higher potential, its potential energy increases. If I want to move it from lower potential to higher potential, then I should do work. If I want to move it from lower potential to higher potential, I should do work. Got it? So here, if I move a charge Q is equal to 1, Q is equal to 1 coulombs, and voltage, potential, I will measure it in terms of volts. Then, and supposing this is at lower potential, and this is at higher potential. This is at lower potential, this is at higher potential. Now, I take a charge of 1 coulomb and move it from here to here. What did I do?
You moved the V1 towards
What did I move?
V1.
I didn't move V1. V1 is the potential at the point.
Sorry,
I moved the charge from a point V1 to another point V2. V1 is at lower potential, V2 is at higher potential. Got it? V1 is at lower potential, V2 is at higher potential. Got it? Okay? Now, you see, if I move this pen from this potential to this potential, I will do some work. Hello?
yes, sir.
How much work will I do? I will do some work. This work will get converted to energy. Correct? Similarly, if I have to move a 1 coulomb charge from this point to this point, I will do some work. Do you appreciate?
Yes, sir.
Hey, Bulldor, yes, Sagisandale.
Yes, sir.
Yes, sir.
If I move it from lower potential to higher potential, I will do some work. Now, if I take test charge 1 coulomb and move it from this point to this point, okay, I have done some work. Got it? Hello?
Yes, sir.
Now, supposing the potential difference between these two is 1 volt. Supposing that is V2 minus V1 is 1 volt or V1 minus V2 1 volt. Got it? V1 minus V2 is 1 volt. Then the potential difference 1 volt means to move 1 coulomb charge from here to here, I will expend 1 joule of energy. If the potential difference between these 2 points is 1 volt, then I will expend 1 joule of energy to move 1 coulomb of charge. If I move it from this point to this point, if I move it from this point to this point, if the potential difference, if this is at higher potential than this, if the potential difference is 1 volt, what did I say?
If the potential difference is
Potential difference is 1 volt.
And if I move 1 coulomb charge from this point to this point, then I will expend 1 joule of energy. Got it?
yes, sir.
Hello?
Yes, sir.
Now.
Anyone should fix, sir?
Ask.
No, sir, can I one once repeat that, sir.
Okay. Now, if I move 1 coulomb charge from this point to this point, which is at a potential difference of 1 volt. This is the lower potential, this is the higher potential. Then I will expend 1 joule of energy for every coulomb. Then the potential difference is 1 volt. If the potential difference is 1 volt, and if I move 1 coulomb charge from lower potential to higher potential, then I am expending 1 joule of energy.
Yes, sir.
The person who asked question did not say yes.
I will recall, sir.
Okay, I am getting confused with your voice. Somebody's voice is also similar. Okay, now, if you have understood what I have told, if I understood what I have told, so then you have to tell this. Okay. Now, can you see a cell here? Hello? Hello?
Yes, sir.
Yes, sir.
Now, you can see that one point is at higher potential, one point is at a lower potential. Okay? Now, if you take an ordinary cell, battery cell, it is written as 1.5 volts. Correct? Hello? Now, what does that 1.5 volts? That battery cell has got 1.5 volts. What does that signify? 1.5 volts.
The potential difference between
The potential difference between the positive and the negative terminal is 1.5.
Excellent, excellent. Thank you so much. Right. Now, in this circuit, that 1.5 volts means what? See, look at this circuit. I have connected the circuit. Now, in terms of whatever I told now, you try to explain. Try to explain. I know you will not explain correctly, but try to explain. Now, in this circuit, what does that 1.5 volt means?
So to move that when charge is supposed at the positive terminal, it takes 1.5 joule to move from positive to negative terminal.
How much charge? How much charge? How much charge? How much? See, what you told is 90% correct. 10%. You said energy spent to move a charge from positive potential to negative potential. Correct? You said a charge. How much is the quantity of charge? You only told Mr. Aryan that the potential of positive terminal is 1.5 volts with respect to negative terminal. Correct?
Yes, sir. Yes, sir. Potential difference.
You told that now?
Yes, sir.
Now I asked what does it mean in this circuit? Sannidhi told a charge is moved from positive potential. It is the work done for moving a charge from positive terminal to negative terminal. Correct, Sannidhi?
Yes, sir.
Now you use the word a charge. What do you mean by a charge? What you should have told is, if, listen here, if 1 coulomb of charge, if 1 coulomb of charge leaves the positive terminal, moves through the resistor or whatever load I have connected and returns back to the negative terminal, then the battery would have performed 1 joule of work. Did you understand? If you have understood, you repeat.
So one coulomb.
Yes, all of you shout. I can hear all of you. Don't worry. Tell.
Once again, I repeat, sir.
No. Those who have heard me, please answer.
one coulomb,
Mr. Aryan, others are telling, you listen. Loud. You also tell.
1 coulomb of charge from the positive terminal through the circuit and through the resistor to the and comes.
Why are you seeing here and there? You see here, Sankalp, you see the circuit is here. Why are you seeing here and there? Look at this and tell no.
1 coulomb of charge from the positive terminal.
No. See. You are all by hearting. You are all rot mechanism. You are by hearting. See the action. You are putting your head down. You are doing like this. You are seeing here. All that shows you are in the habit of by hearting and reproducing answer. When you have the thing in front of you, you are not ready to see. Come on, very simple. See here from the positive terminal. If 1 coulomb of charge starts from the positive terminal, it travels like this and comes here. Then this battery, if the potential difference between these 2 points is 1 volt, then this battery has performed, this battery has given energy, this battery has done work equal to 1 joule. Because it has transported 1 coulomb of charge. Did you get it? Hello, everybody?
Yes, sir.
Now, if the battery potential is 1.5 volts, okay, then this should have performed 1.5 joules of work. The battery will perform 1.5 joules of work for every coulomb of charge to be transported around the circuit. Now, please, students, understand. You lift a brick from here to here. Hello?
Yes.
You did some work. You have done, say, 10 joules of work. How much energy did you spend? 10 joules of energy. I spent 10 joules of energy and did 10 joules of work. Similarly, this battery will perform 1.5 joules of, it will expend 1.5 joules of energy, and it will perform, and since it has expended so much energy, 1 coulomb of charge was able to flow from here to here. The charge will not flow from here to here on its own. Somebody has to push it. That is why I use the term electromotive force. I use the word electromotive force. Now this is mechanical force. There I will use the term electromotive force. Electromotive force means not push and pull. I showed you merry-go-round. What does your uncle do? He is doing like this and you are revolving. Battery is also doing the same thing. It is energizing the electrons to complete its journey through the circuit. And every time a journey is completed, that means the charge will leave the positive terminal and come back to the negative terminal. It has to expend some energy. How much energy does it expend? Now, if the battery potential difference is 1.5 volts, then it will expend 1.5 joules for every coulomb that it sends. Correct? Hello?
Yes, sir.
Yes, sir.
Anybody is having doubt here? Yes, because you will have numericals on this. You will not be able to solve the problems. Then you will come and say, my son, my daughter knows everything, all theory she knows and he knows, but some adak burudil. Problem adak burudil and artha, theory artha agil.
Volt means how much volt, that much joule, no, sir.
That much joule per, no, alli artha thindu bitta. You gainer quarter artha thindu bitta ನೀವು. 1 joule per coulomb. ಏನಂದೆ?
1 joule per coulomb.
Per ಏನಂದೆ ಅದ?
Coulomb.
Coulomb. Okay. Now, let me see. Aryan, be ready.
Yes, sir.
So, you have asked so many questions. I will ask questions to you. Right. Now, instead of transporting 1 coulomb, if it transports to 2 coulombs, the active potential is 1.5 volts. And instead of 1 coulomb, it transports 2 coulombs. Then how much energy does it expend?
So what is the volt?
3 is also.
1.5 volts. The potential difference is the potential difference between these 2 points is 1.5 volts. And if 2 coulombs of charges move, if 2 coulombs of charge move from here to here, then how much energy did it expend?
3 joules per
3 joules.
to move to
3 joules for 2 coulomb.
3 joules for 2 coulombs. Understood now? Hello?
Yes,
If the battery potential difference is 1 volt, then if it has moved 2 coulombs, then how much energy did it expend? 2 joules. Understood now? Understood? This is the significance of the potential difference. Battery the potential difference istada andre ಏನು ಅರ್ಥ ಮಾಡ್ಕೋತೀರಿ? ಅರ್ಥ ಏನು? Potential difference ಈಗ V volts ಇತ್ತಂದ್ರೆ it means that battery will expend V joules of energy for every coulomb that it transports. Significant. If somebody is moving in a Mercedes car, what does it signify? It signifies that person is, so many significance you can take. That person is very rich. that person is so and so, so and so. You can give so many attributes to that person. He is very stylish, whatever you want to think. Yes or no? It manifests. Hanga nam physics olaga, if the potential difference is 1 volt, that means the battery, if the potential difference of the battery is 1 volt, or between any 2 points, if the potential difference is 1 volt, then between those 2 points, if you want to move a charge, 1 coulomb charge from lower potential to higher potential, then you have to expend 1 joule of energy. Or if the battery itself is the source of energy, then it expends 1 joule of energy for every coulomb to be transported. Is that clear? No, ಇವತ್ತು ನೀನು ಇದ ಸ್ಲೈಡ್ ಕಳ್ಸೇನಿ ಇದ 60 ಸ್ಲೈಡ್ ಕಳ್ಸೋದೈತೆ ನನಗೆ ಇಂತ ನಿಮ್ಮ 10th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಪೋರ್ಷನ್ ಮುಗಿಸಬೇಕಲ್ಲ.
So, you told that to move from lower potential to higher potential, which means that does it mean that the negative terminal is at a higher potential than the positive?
Ha, good question. This is a good question. This is a nice question. Okay. Right. Okay. So now this is at potential V1. This is at potential V2. Right. Now in that example I told that this is negative, I write it at minus, I write it at plus. What does it mean?
V1 is at a lower potential than V2.
Good. Here is a lower potential than V2. Now I will take a positive charge. Keep it here. And then move it here. Okay? Then, what is the work that I have done? The work I have done is, see, now first I will calculate the potential difference. V1 minus V2. Now be careful. So I written here minus, I wrote here plus. Note. V1 minus V2. I did V1 minus V2. Okay. So I will get some number to this. Okay. Now, what does this number signify?
The potential difference with V1 with respect to V2.
Potential difference V1 with respect to V2. Okay. So whether it is plus or minus, this is what I am going to write. Now I write this as plus and this as minus. So the way we calculate will not change. Hello. The potential of this with respect to this, or the potential difference between this and this is so and so. Got it? Hello? Okay. Now listen. I will still take plus Q charge here, place it here. I'll still take plus Q charge and place it here. Okay? Then assume that this path is conducive. That means the charge can move. Then if I place a charge plus Q at this point, then this charge, what will happen to this charge if I place it at this point, and supposing there is a conductor connecting these two? What will happen to this charge if I place it here? If I place the charge Q here, what will happen? This is at a higher potential than this. Hello?
Yes, sir.
Hello?
Yes, sir.
So this charge will automatically move from here to here. Got it?
Yes, sir.
Just like how if I leave my hand, this will automatically move. Got it?
Yes.
Hello?
Yes.
Why did it move automatically? From this point to this point? Higher potential to lower potential. Same way, if you keep plus Q charge here, it will move here. Okay? And this is what happens. Now, what is the change in the energy of this charge, of this body? Here it is mgh1, and at this point it is mgh2.
Yes, sir.
mgh1, this is h1 and this is h2. mgh1 minus mgh2. What is this? The difference in the energy. Hello?
Yes.
So this charge had energy here qv1, and when it reaches here, this same charge will have energy qv2. What is the difference in the potential energy of the charge? qv1 minus qv2. What is this? Difference in the potential energy. Now you do the manipulation. Q into v1 minus v2. What is this? This is the difference in the potential energy of the charge since it has moved from here to here. Did you understand this point, or if you have any question, you ask it?
Can you repeat it, sir?
Okay. Now whatever I have written, you see and think. Whatever I said down, you think. You have any question? Ask.
Means that at the last, sir, means it is the potential difference between V1 and means you can even do it like V2 with respect to V1.
I can do, but why? See, when I am giving a condition, I am asking you to learn. Did you learn from what I have taught? That is next question. First, what I have taught, did you understand? You tell. That is next question. What I have taught, did you understand? Everybody.
No, so that we multiply with Q so that we get potential energy. No, sir.
Yes, to get potential energy.
Okay. See, here both the charges are same.
Both the I told you place a charge Q here and this charge will move from here to here and carry the low.
No, sir.
The same charge will move. So this charge, when it is at this point, its energy is QV1. And this charge, when it moves here to this point, its energy becomes QV2. This pen has energy mgh1. And when it comes here, this pen will have energy. When this pen comes here, this pen will have energy mgh2. So the gravitation did work. That much energy was expended by the gravity. Understood? So similarly, if you leave it and if there is a conductor here, this charge will move from here to here. Slow kalitiri. Yak slow kalitiri katara shraddheyinda na helid kelavallri ನೀವು. ಸಮಾಧಾನ ಕೇಳಬೇಕು. ಪ್ರತಿ ವರ್ಡ್ ನ ಹಿಡಿದು ಬಹಳ ಸೀರಿಯಸ್ ಆಗಿ ತಗೋಬೇಕು. ಮನಿ ಒಳಗೆ ಹೋಗಿ ಓದಬೇಕು. ಅಂದ್ರೆ ಬರ್ತದೆ. So the potential energy, see, ಇದೆಲ್ಲ numericals are the potential energy at this point, so the potential difference is so and so. Now if I manipulate it, I'll get Q into V2 minus. What is V2 minus P1? Potential difference between these two points. And what is Q? Q is the charge that has moved from here to here. So that means, what does this signify? It says that the agency which is moving it from here to here has to expend this much joules of energy. This much joules of energy, because it is transported Q charges. Q into potential difference. Q may be 1 coulomb, 2 coulomb, 3 coulomb. Potential difference can be 1 volt, 2 volt, 3 volt, 5 volts. If 5 coulombs of charges are transported and the potential difference is 6 volts, then the energy expended by the agency to move it from here to here is 5 into 6 is 30 joules.